Hello, welcome to Par Excellence Tutorials. And in this video, we are going to tackle a vector question, but a little bit advanced vector question from those vectors that we do at secondary school or at secondary level. Yeah, so here we are going to use, okay, we have a scalar and we're going to use an operator that is going to operate on this scalar and giving us a vector. So we are going to use an operator here, which is called a Nabla or del operator. So this Nabla operator is mathematically defined as like this. Okay. So it is defined is a vector, of course. Partial differentiation in X plus partial differentiation with respect to Y. And then, so this is in 3 dimensions. Okay, so this is in 3 dimensions. So this is how a Nabla operator is defined. So this operator is going to operate on this scalar here, and it's going to change the face of this scalar once it is operated on. So we let this scalar, okay, let this scalar be this is 5, or let it be 5, or but this is not 5. Let that be this scalar. So it's squared. So x squared y plus x z 3. Okay. So we say Nabla operating on 5, which is going to be like that. X z, then have plus so this Nabla is going to operate on the whole of this scalar. Okay, so this is actually partial differentiation. This is partial differentiation. So here we are going to differentiate x only where there is x. Here we are going to differentiate only where there is y, and here we are going to differentiate z in short, or we're going to differentiate z here, we're going to differentiate y and x here only. Okay, so this is going to give us here, if we differentiate x, in the first part, we get 2x, y, and then we have x also on the second part, which is going to give us, once we differentiate x, we get z. Okay, we don't forget the unit direction. And then we go to the second one. Here we have y, and then we differentiate y, we get x squared. Okay, so the other variables are constant, are going to remain constant as you are differentiating what you're differentiating with respect to. So here we don't have y, so we can't differentiate with respect to y, x, z, so it's 0. And then we go to the last part. In the first part of this scalar, we don't have z to differentiate. So this is going to be 0. So we differentiate z there, we get x with k. So now we've been taught to say find a unit vector normal to the surface. So this is a surface at the point 1, -1, 1. So these are actually values for X, Y, and Z. This is a position. So this is a coordinate. So we replace wherever there is X, we replace with 1. Wherever there is Y, we replace with -1. And wherever there is Z, we replace with 1. So we are going to get 2, 1, -1, +1. Okay. After substituting, and then here we get 1 squared J. Then here we get 1 K. Okay. So if we do the mathematics, we get -2 + 1, which will give us -1. So just -I. And then here we just get J, and there we get K. So this is a vector. So now what we are looking for is a unit vector. Okay, we are looking for a unit vector. So we've just found a vector, but now we are looking for a unit vector. So how do we find a unit vector? The first thing that we need to do is to find the magnitude of this vector. So how do we calculate the magnitude? So magnitude of this is going to be the root of -1 squared plus 1 squared plus 1 squared, of which this is going to give us √3. So once we find the magnitude, we know that a unit vector, let's say n, is going to be given by the vector, but its own magnitude. So the vector is actually -I plus J plus K, and then we divide by the magnitude. So this is going to be 1√3. Okay, so let me write it from here on top. So what we're going to have is this unit vector is going to be 1/√3 -I plus J plus K. Okay, so if you want, you can distribute the 1√3 throughout, and then you're going to have unit vector like that. So this is how we calculate or find the unit vector. So have you found this video helpful to you? So if you have found this video helpful to you, kindly subscribe to the YouTube channel, and don't forget to click on the notification bell so that you get notified each time I upload a new video. And you can like as well, you can share with others. So thank you so much for watching.